You've probably noticed by now that as you get farther and farther into math, you start to see fewer and fewer numbers and more letters. And it's true, actually. This continues on even into calculus and into college math. You get to see, you start to run out of English letters. You start to use Greek letters, and then you run out of Greek letters, and then who knows what happens. But this is a literal equation right here. P equals 2L plus 2W, this formula for the perimeter of a rectangle. It's called a literal equation, and we call it that because there's more than two different kinds of variables in it, or more than one different kind of variable in it. If everything was just x, it would be a regular equation. You could solve that equation for x because there's only x. But there's more than one letter here. So if we're going to solve, we're going to end up just rearranging the terms in here. We're not going to get that, in this case, w. We wanted to solve for the width, w. We're not going to get w to be equal to a number. We're going to be equaling some other form of this formula. So to actually do this, well, again, it actually works pretty much the same way as any other kind of equation. The only difference is that when we add or subtract or multiply or divide, in some cases we're not actually going to be able to combine stuff. So P equals 2L plus 2W. If I'm solving for the width, that means I need to get rid of everything on the right-hand side here that isn't the W. I need to solve for W. I'm isolating the W. So if this were just a regular equation, if this was just 2 plus 2W, I'd subtract the 2, this 2, to over here, and then I divide by 2. Well, the fact that this is a 2L doesn't change that at all. I'm still going to subtract the 2L from both sides. The only thing is, of course, I can't combine these. That's a P, that's an L. I can't actually combine those. So I just have to kind of leave it like P minus 2L equals 2W. And then from there, I divide by 2, and I get that, well, they cancel over there, I get that W is equal to, just switching the sides around, P minus 2L all over 2. So this is one way I could write the answer. Now, if it feels like it's not all that great, because there's kind of 2's everywhere, it feels like there should be a simpler way to do this. You're right, actually. There's another way that we could simplify this formula. Again, P equals 2L plus 2W. And just to realize, these both have 2's. So imagine that the distributive property was used here. That we had some situation where there was a number or a letter outside of a set of parentheses, and there was a sum or a difference inside, something like, 3 times x plus 2, something like that we would then multiply the 3 all the way through. We could reverse it. We see that there's a 2 in common here, so we could pretend, well, what if that was just a finished version of the distributive property? We can undistribute. This is actually called factoring, which is a term that you might already be familiar with, but if not, we'll be spending a lot of time later on in the course talking about. So now I have 2 times L plus W, and I treat this L plus W in parentheses as one solid block, meaning that I can divide this side by 2, and they'll cancel from over there. Divide that side by 2 as well. I get P over 2 is equal to L plus W. I haven't actually isolated the W yet. I need to finish doing that. And I finish doing that by subtracting the L. Minus L, again this is through the equal sign there, and I get P over 2 minus L equals W, or W equals P over 2 minus L. So I get actually 2 different forms for this expression, or for this formula. But they're the same. If I plug in a value for P and L here and a value for P and L here, I'll get the same value for W. You should check this on your own. But it's just 2 different strategies to reach 2 slightly different looking answers. Ultimately, they're the same thing.